वेव्स एंड सुपरपोजिशन की बात करेंगे। तो वेव्स एंड सुपरपोजिशन इज सच अ टॉपिक के दैट टॉपिक कंसिस्ट ऑफ मेनली इंटरफेरेंस, डाइफ्रैक्शन, ठीक है, एंड यस सुपर स्टेशनरी वेव्स एज वेल। लेकिन इसको हम लोग एक लिहाज से आप यूं समझ लो कि हम थोड़ा सा आगे लेके चलेंगे जब एडवांस लेवल पे, तो वी कैन मैनेज दिस ऑल कि सुपरपोजिशन को हम लोग पहले इंटरफेरेंस और डाइफ्रैक्शन में लेके जाएंगे। इसके बाद फिर हम लोग अगले पॉइंट पे आएंगे जहां पे हमें ये सारी की सारी चीजें देखनी पड़ेंगी कि आया स्टेशनरी वेव्स क्या हैं, और स्टेशनरी वेव्स को हम लोग मतलब एक्चुअली सुपरपोजिशन का ही एक आगे फर्दर एक्सटेंशन है, आप यूं समझ लें। तो इसलिए जब हम लोग इस टॉपिक पे हों तो आपने ये जो मेन आइडिया सुपरपोजिशन का मैं आपको दूंगा उसको भूलना नहीं है, ठीक है।
ओके सर।
ओके, तो वैसे यूजुअली जब आपको सुपरपोजिशन की बात की जाती है तो मतलब आपके जहन में क्या आता है, व्हाट इज सुपरपोजिशन, या आपको क्या लगता है सुपरपोजिशन क्या होना चाहिए?
सॉरी सर, रिपीट करें।
सुपर इम्पोज किसको कहते हैं? मैं ये कह रहा हूं कि आपको आपके उसके मुताबिक सुपरपोजिशन या सुपर इम्पोज किसको कहते हैं?
सुपर पोजिशन, सुपर इम्पोज किसी चीज के,
सुपर इम्पोज,
किसी चीज को मतलब कि इम्पोज करना, उस पर सख्ती करना।
यस, एक चीज ऑलरेडी है उसको थोड़ा सा री इन्फोर्स करना, टू समहाउ दोबारा उसको इम्प्रूव करने के लिए कुछ और फोकस करना, या इन दिस वे सुपरपोजिशन मतलब कि overlapping of two ideas, simply overlapping of two ideas. So when two waves overlap at a point, yani at any particle, in such a way that resultant displacement of the wave or the particle uh, is changed, or we can say that is the algebraic sum of individual displacements, उस प्रोसेस को हम लोग क्या कहते हैं, सुपरपोजिशन कहते हैं। लेकिन ये सिर्फ अकेला सुपरपोजिशन का ये मैकेनिज्म नहीं है। ऐसे मैंने क्योंकि अपने सिलेबस के पॉइंट ऑफ व्यू से ये सुपरपोजिशन को ये डिस्कस किया हुआ है, आपके पास सुपरपोजिशन में फ्रीक्वेंसीज भी चेंज होती हैं, आपके पास सुपरपोजिशन में एम्पलीट्यूड भी चेंज होता है, रिजल्टेंट डिस्प्लेसमेंट वगैरह, ईच एंड एवरीथिंग। तो आपने ये याद रखना है कि हियर वी आर गोइंग टू डिस्कस अबाउट द सुपरपोजिशन ऑफ एम्पलीट्यूड, ठीक है, सुपरपोजिशन ऑफ एम्पलीट्यूड या डिस्प्लेसमेंट। तो जब आपके पास दो या दो से ज्यादा वेव्स इस तरह मैच अप करें, ओवरलैप करें कि रिजल्टेंट डिस्प्लेसमेंट इज algebraic sum of individual displacement, तो उसको हम लोग क्या कहेंगे, यहाँ पे सुपरपोजिशन कहेंगे। फॉर एग्जांपल इफ आई हैव टू वेव्स, यहाँ पे देखो वन वेव हैज अ रेड वाली वेव, दिस वेव हैज द एम्पलीट्यूड ऑफ लेट्स से 0.5 सेंटीमीटर, ठीक है, ये, एंड दैट वन, ये जो ब्लू वाली है दूसरे वाली वेव, इसका एम्पलीट्यूड आपके पास है जी 1.0 सेंटीमीटर। सो इफ बोथ द वेव्स आर इन सच अ वे कि जहाँ पे जो पार्टिकल है इन इक्विलिब्रियम पोजीशन, बोथ दैट इज बेसिकली लिफ्टेड अप बाय बोथ वेव्स एट अ टाइम, तो ओवरऑल डिस्प्लेसमेंट उस पार्टिकल में क्या होगा, दैट विल बी 1.5 सेंटीमीटर, इज इट? सो दिस इज बेसिक प्रिंसिपल ऑफ सुपरपोजिशन, जिसको हम लोग आगे चल के कहेंगे कि सुपरपोजिशन, प्रिंसिपल ऑफ सुपरपोजिशन मींस कि the resultant is, ये आपसे पूछता भी है just for 2 marks, what is the principle of superposition? The resultant displacement is the algebraic sum of individual displacements. Resultant displacement is the algebraic sum of individual displacements. मतलब for example if one wave is having, or one wave causes the displacement d1 in a wave, in a particle, and other wave causes a displacement d2 in that particle, or at that point, ठीक है, तो resultant displacement आपका क्या होगा, that will be d1 plus r minus d2. d1 plus r minus d2 means there are some conditions जिसके ऊपर हम लोग आगे चल के बात करेंगे कि अगर आपके पास कुछ conditions ऐसी होंगी in which d1 and d2 will be added together, and there would be some conditions in which d1 and d2 will be subtracted from each other. That can also be written as x1 plus x2. That can also be written as y1 plus y2 या y1 plus minus y2. So ये depend करता है आपके पास एम्पलीट्यूड किस में गिवन है। यूजुअली हमारा जो एम्पलीट्यूड होता है या डिस्प्लेसमेंट होता है वाई एक्सिस पे होता है, सो दैट इज व्हाई वी कैन कंसीडर इट वाई, ठीक है। इज दिस क्लियर टू ऑल? मूसा ने ज्वाइन किया, यहिया ने, सॉरी।
एक सर यही नहीं चाहिए।
ओके ओके ओके। तो आफ्टर दैट वी हैव कंडीशंस फॉर, मैं इसके बारे में बात कर रहा था कि आपका सुपरपोजिशन की कंडीशंस क्या होनी चाहिए, यानी क्या क्या कंडीशंस है, किन किन कंडीशंस में आपकी सुपरपोजिशन हो सकती है। तो सबसे इंपॉर्टेंट चीज कि वेव्स आपकी सेम टाइप की होनी चाहिए। साउंड साउंड में सुपर इम्पोज हो सकती है, लाइट लाइट के साथ सुपर इम्पोज हो सकती है, कोई भी इलेक्ट्रोमैग्नेटिक वेव के साथ सुपर इम्पोज हो सकती है, लेकिन अपनी टाइप की। फॉर एग्जांपल मैंने अभी बोला कि लाइट लाइट के साथ सुपर इम्पोज हो सकती है, ऑल्दो आपकी जो माइक्रोवेव है वो इलेक्ट्रोमैग्नेटिक है, लेकिन वो लाइट वेव नहीं है, इसलिए वो आपस में सुपर इम्पोज नहीं हो सकती। तो आपकी दो वेव्स सिर्फ तब सुपर इम्पोज होंगी जब उन दोनों की नेचर एक जैसी होगी, टाइप सेम होगी। Then the wave must be monochromatic. That is, they must have same frequency, same speed and same wavelength. आपसे ये भी पूछता है कि what does it mean by monochromatic? तो मैंने इसीलिए इसको अलग कलर से लिखा हुआ है कि monochromatic। वो आपसे पूछता है तो you have to be very careful about monochromatic is basically when two waves have same frequency, you have two waves of same frequency, same wavelength and same frequency, उन waves को हम लोग क्या कहते हैं, those are called your monochromatic waves, ठीक है।
जी सर समझ गया।
अच्छा, उसके बाद द वेव्स मस्ट बी कोहेरेंट। अब कोहेरेंट वेव्स आपकी बेसिकली वो होती हैं जिन वेव्स का फेज डिफरेंस सेम होता है थ्रू आउट। ये भी मैं आप लोगों के साथ शेयर कर डिस्कस कर चुका हूँ कि हाउ टू कैलकुलेट फेज डिफरेंस। तो कोहेरेंट वेव्स हैव सेम फेज डिफरेंस थ्रू आउट, मतलब अगर दो वेव्स एक दूसरे से 120 डिग्री आउट ऑफ फेज हैं तो दे विल रिमेन 120 डिग्री आउट ऑफ फेज थ्रू आउट देयर जर्नी। इट्स नॉट के at initial stage of their journey they are 120 degree out of phase and then they are getting to 130 150 and so on. They will be 120 degree out of phase forever, ठीक है। so that is coherence, एक ही फेज डिफरेंस होना चाहिए। यानी इसका एक सिंपल सा लिंक ये है कि द वेव्स मस्ट बी प्रोड्यूस फ्रॉम द सेम सोर्स। मतलब अगर हम आगे चल के जब मैं यंग्स डबल स्लिट एक्सपेरिमेंट की बात करूंगा आपके साथ, तो यू विल बी एबल टू नाउ कि हम जब आइडेंटिकल वेव्स की बात करते हैं, या जब हम लोग बात करते हैं मोनोक्रोमेटिक वेव्स की, या जब हम लोग कोहेरेंट वेव्स की बात करते हैं, तो वी यूजुअली प्रोड्यूस द वेव्स फ्रॉम द सेम सोर्स। तो सेम सोर्स से वेव्स जो भी प्रोड्यूस होंगी दे विल बी योर मोनोक्रोमेटिक एंड कोहेरेंट वेव, ठीक है। अब देखो,
ओके सर।
उसके बाद हमारे पास आ जाता है द consequences ऑफ सुपरपोजिशन। यहाँ पे बात हमारी आगे चलेगी। द consequences ऑफ सुपरपोजिशन आर बेसिकली थ्री, जिसमें से हमने दो डिस्कशन करनी है एंड थर्ड वन इज आउट ऑफ सिलेबस। इंटरफेरेंस ऑफ द वेव्स, सो व्हेन टू वेव्स इन सुपर impose with each other, yeah, when two waves overlap with each other, the resultant this procedure can be called as interference of waves। रिजल्टेंट को हम लोग क्या कह सकते हैं, इंटरफेरेंस कह सकते हैं। अब आप देखो इंटरफेरेंस के लिए क्या शर्तें हैं, ये जो ग्रीन में मैंने लिखी हैं, दीज ऑल आर द इंटरफेरेंस कंडीशंस। द वेव्स मस्ट बी मोनोक्रोमेटिक, दे मस्ट बी कोहेरेंट एंड मूविंग इन द सेम डायरेक्शन। दिस इज कंपल्सरी कि वेव्स क्या होनी चाहिए, they must be moving in the same direction। amplitude of the wave can be separate, यानी can be same and that can be different। फिर उसके बाद आपके पास आ जाता है सेकंड सेकंड यानी आउटकम ऑफ द सुपरपोजिशन इज स्टेशनरी वेव्स। तो स्टेशनरी वेव्स means when two monochromatic and coherent waves moving in opposite direction overlap each other, उनकी फ्रीक्वेंसी, उनकी स्पीड, उनका एम्पलीट्यूड सब कुछ क्या होना चाहिए, सेम होना चाहिए। अब देखो इंटरफेरेंस में और स्टेशनरी वेव में दो शर्त यानी दो कंडीशंस है। पहली कंडीशन ये जो दो कंडीशंस का डिफरेंस ये है कि the waves must be moving in same direction for interference and waves must be moving in opposite direction for stationary waves। ठीक है, आपको मेरी आवाज क्लियर आ रही है?
जी सर क्लियर आ रही है।
ओके। और तीन चीजें इनकी सिमिलर हैं, वेव सेम टाइप की होनी चाहिए, मोनोक्रोमेटिक होनी चाहिए, कोहेरेंट होनी चाहिए, ठीक है, और एक ही मीडियम में होनी चाहिए। और दूसरा जो डिफरेंस था वो मैंने आपको बताया कि इंटरफेरेंस में एम्पलीट्यूड सेम हो तब भी चल जाता है, ना सेम हो तब भी चल जाता है, लेकिन स्टेशनरी वेव्स में एम्पलीट्यूड यानी डिस्प्लेसमेंट वेव्स का सेम होना जरूरी है। तीसरी जो चीज है दैट इज बीट्स। बीट्स मैंने आप लोगों को बताया कि बीट्स आर बेसिकली एक्सक्लूडेड फ्रॉम द सिलेबस, बट वी कैन सिंपली से बीट्स जो हमारी म्यूजिकल बीट्स होती हैं, वी कैन टॉक अबाउट के आप डिफरेंट फ्रीक्वेंसीज के इंस्ट्रूमेंट्स म्यूजिक में हम लोग प्ले करते हैं ना, ठीक है, डिफरेंट मतलब इंस्ट्रूमेंट्स, फॉर एग्जाम्पल हमारे पास वायलिन है, गिटार है, उन सब की फ्रीक्वेंसी डिफरेंट होती है, बट व्हेन दोज वेव्स ओवरलैप ईच अदर तो हमारे पास जो एक नोड बनती है उसको हम लोग म्यूजिकल नोड कहते हैं ना, ऐसे ही है ना। तो बीट्स इसको कहा जाता है व्हेन टू वेव्स ऑफ डिफरेंट फ्रीक्वेंसी ओवरलैप ईच अदर एंड द रिजल्टेंट फ्रीक्वेंसी इज either less or more than the individual frequency, उसको हम लोग क्या कहते हैं, बीट्स कहते हैं। ये बात क्लियर है?
यस सर क्लियर।
ओके, इधर गया हमारा, यस, ये मैंने म्यूजिकल बीट्स या एनवेलप्स बनाए हुए हैं। अस्सलाम वालेकुम, यही आर यू देयर?
Alaikum salam, sir. Yes.
Oh, okay. So envelopes of beads are something like that. For example, as we were talking about, the topic basically superposition, right? Superposition is of two.
Ah,
Superposition has three results. Yes. Do you hear me?
yes.
यस सर।
Okay. Yes. Yeah. You were saying something.
No, I can hear. That's what I said.
Okay. So just starting from here, basically, superposition was a concept of overlapping two or more waves at a point, and during superposition, basically, the waves must be coherent and monochromatic. These are two ideas which you must know about, and these two ideas are we just discussed here. Yes, what is coherence? Coherence is when the waves are of the same source, okay, when the waves are coming from the same source or their phase difference is same throughout, so those waves are called your identical waves, or you can say the waves with the coherent waves probably, okay, they are coming from the same source. And monochromatic waves are those waves which are basically of the same wavelength, same frequency, and same speed. So if we have these type of waves, we call them the monochromatic and coherent waves. So for interference, we must have the waves which are monochromatic and coherent waves. So we were talking, Mohsin and me, that in interference, these type of conditions are required, that waves must be monochromatic, coherent, and moving in the same direction. This is very important. Amplitude of the waves can be different or can be same, it does not matter, but they must be moving in the same direction. And during interference, the resultant will be the displacement will be algebraic sum of individual displacements, like displacement can be added or displacement can be subtracted. Then stationary waves were there. Stationary waves are having same conditions, some of the conditions monochromatic, coherent, but they must be moving in opposite direction. They must be moving in opposite direction, and their frequency, speed, amplitude, everything should be same. For interference, amplitude can be different, amplitude can be same, but here everything should be same. Then when we talk further, we came to now that were beats were yes, we were talking about the musical beats. That beats are the resultant or superposition of two waves which have different frequencies, right? I was talking about the musical beats, like your violin, your guitar, different musical instruments, they have different frequencies, and when we just play them together, the waves superimpose with each other, and when the waves superimpose with each other, what happens as a resultant, yeah, as a result, we get a musical beat or musical note, and that musical note is something here, that you will have some over, yani you will have some envelopes of beat. So this is excluded, it is not included in the syllabus. I just shared this information with you. So I believe that when in your higher level, whenever you will go to study physics, yes, yeah, you have to definitely. Then you people will know about the beats. Then there is another uh, phenomena we have to study. This is really important because this phenomena will help me to study about the interference specifically. So you people have studied the diffraction in your previous levels, right? Both of you, na? Yes, Afan and sorry, Yahya and Mohsin. आप
Yes,
लोगों ने
sir.
diffraction पढ़ा कभी? Diffraction.
Uh,
So diffraction is basically when a wave passes through a narrow slit or a narrow opening, what happens? The wave bends, right? The wave bends. Yani, if you have some sort of obstacle, like this is one of the obstacle, this is the other obstacle. Oh, okay. This is the, yes, it can be duplicated, and this is the obstacle, and waves are passing through that, and when waves are passing through that, you can simply say that all the particles would not be able to pass through at once. When all the particles are not able to pass through at once, what will happen? Those particles which are over here, they will cross it first, and remaining particle will come side by side. So in this way, the there would be a bending caused. This is basically called diffraction. I have a detailed discussion inshallah about that. Yes, here is here are some details of diffraction. Yes, these all are the diffraction patterns. So we will discuss this in detail. Okay. So in diffraction, basically, you have to talk about two conditions which are really important for you. One of them is that diffraction has some relationship between wavelength and slit width, opening of the slit. Here is that slit width. For example, if you see, this is your slit width, this is your slit width, and this the difference or distance between two consecutive wave fronts is your wavelength. So wavelength, uh, these are the new wavelets, not wavelengths. So these are the wave fronts. So wavelength of the wave does not change, only it bends. So it is the spreading of the wave through the narrow opening. If your wavelength is comparatively equal to or greater than d, this is wavelength, and this is what? This is your D, split rate, slit separation, then the diffraction will be significant. Yani, it will be visible like this. Did you see here? Here wavelength is big and gap is smaller, or gap is equal to that. So if gap is equal, you can observe diffraction, but if gap is smaller, you will observe a huge bending in the wave. But the case in which wavelength is smaller than gap, yani gap is greater, then diffraction will be a little bit. wave would pass through as it is, little bit edges will be bent, or you will say that only there will be there will be a minor bending on the edges. Got it? Is it clear to you?
Clear है sir.
Okay. Then we have the classification of diffraction. The classification of diffraction is basically diffraction through a single slit, diffraction through a double slit, and diffraction through multiple slits. This is what, this is a sequence of the topic, that when diffraction takes place, diffraction can take place from a single slit. When there will be when only one wavelet or one wave is passing through, it means that there will be no superposition, because there are no two waves. But diffraction for two waves and two slits and multiple slits, there will be interference. Okay, there will be interference. So diffraction through two slits or double slit is called Young's double slit experiments, and diffraction through multiple slit is called diffraction grating. So we have to take care of all these points, that where is the diffraction grating and where we are talking about the Young's double slit experiment, and that's it. Let's say diffraction takes place in all type of waves. For example, here I have given you just few examples. You know, in sound waves, we observe the diffraction because the sound bends when we have a narrow opening for that. Just like woofers, from woofers we have just a small hole opening. So why do we use that? That because wave is not directly pointing towards in front of the speakers or woofers. It spreads out in all over in all over the room. And why do we have a pair of woofers usually? Because of the interference, because both the woofers or both the speakers will produce the wave, and there will be a point where the waves will interfere each other in constructively, and there we can find out the highest value of sound. So here, for example, there is just a simple question to you. This is student B, this is student A. When student A shouts or he utters something, student B can hear, but student B cannot see student A. The reason behind that this opening is very small for sound waves, but it is very big for light waves. That's why the wave is not bending, yani light is not bending here. Light can just reflect, or you can say light will reflect, and when reflect, it will reflect at the same angle. So for that purpose, we can have a mirror here for reflection to see this, just like the periscope, but it is not like that. Similarly, the microwaves or radio waves bend. Due to that, in hilly areas, we have the signals over here. Otherwise, we could not get service in Koita. Got it? So, due to hills, the waves which are just passing over homes, they are just passing by over homes. If there would be no diffraction, but from the edge of this hill or the mountain or the building, the waves bend, and due to bending, they tilt or they bend towards over home, and we can receive this. We can receive the signal, mean we can get the wave. Is it clear to both of you? So you can simply say the diffraction takes place in all type of waves. Now let's talk about, this is really interesting topic, diffraction in diffraction through double slits. Diffraction through double slit. Did you see what I show you here? What is that?
Yes sir.
Till this point. Here are two sources, or you can call them slits. There is a one complete wave beam. It is approaching to the slits. this all is blocked. Ev- Yani entire path is blocked. Just this is a small opening. This is a small opening. Just like it is just like that you have a light, uh, you have a black box, and in that black box you have a light bulb, and that bulb is having, yani this black box has just two openings. So those two openings will behave just like your source of light. Same way, if you just switch on the headlights of your car, rest all of the points in the car are not producing any light, but these two sources. So these two are basically source of light. So very interesting thing. When we drive, we have the maximum light here. Did you ever noticed here? If if you have not noticed, just observe this in future, that this light has a spread like this, and this light has a spread like this. So this is the point where the brightness is maximum, and this is in exact the middle of your car. And you can observe this when the weather is just a little bit foggy. Okay, so when you have two waves, not yani when you have two sources, it's not that only waves are bending. They are bending as well as they are overlapping with each other. So did you notice that all these waves, which are the green color waves, they are the waves of source S2, and all the waves which are of the red color, they are the waves of source 1. So as we are moving, yani here nearby, there is no overlapping. But as the waves are spreading out and out and out, they are overlapping with each other. And all these dots where they are overlapping, these are the points of overlapping. I will take care of these all points. I will consider these points, and we will talk about these. Yani we will talk about this discussion or these point formation in detail. So these points where the waves overlap with each other, either we either the points are called maximas or we call them minimas. Okay, so here I will talk about this. So when waves coming through 2 points, are sorry, through a single source, are passed through two slits, yani a double slit, they behave like a secondary sources of the wave. Yani there are two sources now. The basically the wave which is spreading out and bends is bending and spreading causes overlapping. The wave coming from the second source, that is bending, and this bending causes overlapping of the wave. As I shown you, the overlapping of the wave results interference. Yes, this is the game where when you reach to the point over interference, right? So when the waves will not bend, they will not overlap, and when the waves will not overlap, basically interference will not happen. Or you can simply say that interference will not take place. Got it? Okay. So moving on. Do you people hear me? Is it clear to everyone?
Yes, sir. Clear.
Okay. So there are two concepts which are mandatory before diving into interference. The first concept is the concept of path difference, and the second concept is the concept of phase difference. Because we learned phase difference, but not the path difference. So I would emphasize on phase difference. Sorry, path difference in today's lesson. and with the help of, inshallah, the previous concept of your phase difference, we will construct a concrete concept of interference. So, you know, what does it mean by path difference? I will simply call it the difference of path lengths. For example, I have written that when two waves overlap at a point coming from different sources, they have to travel different path lengths. Is this very clear? For example, one wave is uh, reaching to me from Quetta, and one wave is reaching to me from Islamabad. So both the waves are reaching at once to me, but they are coming from two different resources or different points. It means that we are having the difference of path length traveled by both waves. That difference is called your path difference. Okay, so which causes path difference of waves? It determines how they will interfere, whether the interference will be result in increase in displacement, or it would, the waves will cancel each other. Just see the diagram. For example, from source number one, you are getting a wave, and that wave, that blue wave, it is reaching to point P after traveling 5 centimeters. And from source 2, the wave is reaching to point P that is of the same wavelength. Wavelength will be same, as I told you that the waves will be coherent and monochromatic. So wavelength is same. So simply speaking, when we have this uh, overlapping at point P, at point P, the waves are yani we are supposed to calculate the path difference of both the waves. So according to the given condition, or yani in this condition, what do you notice, or what did you notice? This is 5 centimeter, yani it has traveled 5 centimeter, it has traveled 5 centimeter. So the path difference or difference of path length is zero, is it? Yani they have no difference at all. So we are going to calculate the path difference in terms of lambda. So remember one thing, that when you calculate path difference, just represent path difference in terms of lambda. So path difference is equal to n lambda. This is very, very important formula for you, that this is path difference is equals to n lambda, right? What is your path difference? Path difference is your n lambda. Got it? This is the
Yes.
formula for the calculations of bar difference. Now move to this slide. In this slide, I have shown you that S1 has the same distance from P, so it is 5 centimeter. But S2 has covered one wave length more. So S2P is 6 centimeter, because I have mentioned that wavelength is 1 centimeter. How much wavelength do I have? 1 centimeter. So here path difference is 1 centimeter. Yani, if I say that path difference is 1 lambda, how much path difference? Path difference is 1 lambda. So path difference is n lambda, or you can say path difference is n lambda. Sorry, 1 lambda. So if path difference is 1 lambda, 2 lambda, 3 lambda, you will get the same overlapping situation. So yani that path difference has a multiple of, either it can be of 1 lambda, either it can be of 2, either 3, 4, 5, up to n. So if the path difference is calculated, we can say that path difference is equals to n lambda. That is the equation you have to recall. So now come to this condition. Then finally, I will tell you one mystery about this. Just see it. Again, same wavelength is 1 centimeter. I believe so. And S1 is at 5 centimeter from P. But now S2 is at a distance of 5.5 centimeter. How much distance? 5.5 centimeter. It means 1, 2, 3, 4, 5 and a half. So 5.5 centimeter distance. It means the path difference is 0.5 centimeter. Yani 0.5 centimeter mean, in terms of lambda, lambda is your yani path difference is equal to n lambda. So we have to calculate n. N is equal to how much? 0.5 wavelengths. So we can simply say that path difference is 0.5 wavelengths. In the same way, you can calculate it further, 1.5 wavelength, 2.5 wavelength, and so on. So can you see this n plus 1 by 2 is the general form of odd numbers or point numbers? Got it? So this is very interesting and very important point. And these two slides are basically the core or backbone of your all concept. So you have to take care of this. When the path difference is equal to n lambda, then the waves are said to be in phase, and phase difference is equal to 2 into n pi. Just see, whatever the path difference, yani the path difference of 1 lambda is 2 lambda, 3 lambda, 4 lambda, 5 lambda, and so on. But all the waves would try to shift the particle upwards, na? So it means they are in phase. So you have to recall this situation that when the path difference is n lambda, then phase difference will be 2n pi. This is basically a pair. You have to work on these two. This is if and else. If path difference is n lambda, phase difference is 2n pi. Okay, ji? Is it clear to you? And if your path difference is n plus 1 by 2 lambda, n plus 1 by 2 lambda, n plus 1 by 2 lambda means, just check it, 1, 2, 3, 4. 4 waves, and the green is traveling half extra. So in that case, they are either 180-degree out of phase, you can say, or you can say pi difference. The path difference is, sorry, phase difference is pi. So you have to recall one such situation, that when the phase difference is n pi, where n is 1, 2, 3, yani odd multiple of pi, then path difference will be either 0.5 lambda, either 1.5 lambda, 2.5 lambda, 3.5 lambda, or so on. Is it clear?
Yes, sir, clear.
Okay. So till this point, we have cleared everything, inshallah. And I believe that next one is superposition and interference. So we will talk about that in detail. This is basically a new topic. So I wish that we should start it by next lesson. Okay. Okay, ji? Hello.
जी सर समझ आ गई.
ठीक हो गया. ओके, इससे आगे इंशाल्लाह हम लोग नेक्स्ट लेसन में डिस्कशन करेंगे. And because once I will start the lesson, it would be not be completed, because that is the entire topic, wave type of interference. Okay, so interference will be started in next, inshallah, lecture number 2. See you then. Do you have any question? Any question?
No sir.
Yahya Mohsen. Okay. Yahya gaya? Yahya left?
हाँ जी सर चला गया.
Okay. ठीक है. ओके बच्चे, मोहसिन, चीजें सारी क्लियर हैं?
जी सर क्लियर है.
आपने एक काम करना है इन दिनों में. आपका अभी ये जो पिछला वीक गुजरा, उसमें मैंने आपका ज़रा करंट इलेक्ट्रिसिटी के ऊपर फोकस करवाया था. एंड नाउ यू विल फोकस ऑन वेव्स. जो मैंने टॉपिकल वर्कबुक आपको भेजी है, आप उसके, अगर आपके उसके और टॉपिकल्स पढ़े हुए हैं, तो जस्ट कीप ऑन प्रैक्टिसिंग. ठीक है.